Okay, we are going to try to find the sum of these series on this page. And in order to do so, we either need to get it into a form that is easily recognizable, that is one of the 3 series that we must memorize for the AP exam, or we need to get it to look like a geometric series. So we can put it in the form of a over 1 minus r. So we're going to try that. So we write out our terms, and we change all of those, powers of 3, and we write them in exponential form. And then we see, oh my gosh, it looks almost like e to the x, except instead of x we have 3. So that whole entire sum that looks completely wacky-do is actually just e cubed. Welcome to the lovely land of Taylor series. And again, we write our terms in 2 to the form, exponential form, I don't know what to call it. And we see that it follows a pattern very close to sine of x. Now, in order to recognize these patterns, you really need to memorize those 3 functions, and they were cosine x, e to the x, and sine of x. And here you can almost see their direct relationship. So what we're really looking at is the sine of 2. Doo-doo. Now we're going to try the next one. We haven't used cosine yet. We also haven't used geometric series yet. So we're going to check out which one that is. If you look carefully here, you have an alternating series. The terms are decreasing and getting closer to 0. And you also see that a is 1, or the number in front of each term. You could put a 1 in front of each and every one of these terms. And your common ratio here is negative 2/3. So we can just pop that into the formula a over 1 minus r equal to 1 over 1 minus negative 2/3. And we get 3/5. Sorry. Doo-doo. Okay, I did super wacky math in my head on Thursday, and I am going to take this opportunity to try to clear it up. I don't necessarily think I will, because I definitely do really weird math in my head on this, but I will try my best to explain myself here. If you look, the center of convergence in this power series is at negative 3. And all we know about the radius of convergence, the interval of convergence, is that negative 8 is in that interval of convergence and positive 6 is not. So I'm going to draw a number line because this is how I think about it. And I'm really sorry that I think about it so strangely. Okay, so what we know with just that little bit of information is that for sure 5 units out, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All of that is for sure included. What we also know here is that 6 is not included. So 9 units out is not part of the radius of convergence. Give me a second here. My cat is eating something in French. Okay, so our radius of convergence is somewhere between 5 units away from the center and 9 units away from the center. I'm going to go ahead and label this other piece here. So this would be negative 12. Okay. The power series converges if x equals negative 10. Well, that may or may not be true because it is bigger than that smaller radius that we know for certain is part of the interval of convergence. But it is smaller than the area, than the place where we know for sure it diverges. We do not know what is going on right here. We don't know if the radius of convergence is for sure 5. It could be 6. It could be 7. It could be 8. We don't know. We don't know anything about that information. So we have to say that right here, the power series may converge. And if x equals 1, that is definitely within that blue area there. So this is a must. The power series converges if x equals 2. That is also a must. The power series diverges if x equals negative 9. Well, that's in the part where we don't know what's going on, so we have to say may. The power series diverges if x equals negative 13. Well, that's way off the map, so that is definitely a must. It must diverge. Notice how they suddenly changed up the question. Thank you very much. At the top of this page, they decided to reiterate what's already been said, which is loads of fun. But we're going to move along, and we're going to get into the meat of it, and we're going to find a Maclaurin series for f. And we go through everything we need to do to find f of 0, f prime of 0, f double prime of 0, and f triple prime of 0. We stick that into a Maclaurin series, and we see that f of x, which equals 1 over 1 minus x, actually equals 1 plus x squared plus x cubed plus all the way down to x to the n. Well, for what values of x does the series converge? The values of x for which the series converges would be, well, this is a geometric series, and it would be true for all values, absolute value of x less than 1. So x would have to be somewhere between negative 1 and 1. You do need to test the endpoints. I don't have enough room. I do have that work in my notebook at school, so you can look at that if you'd like. If you can't figure it out on your own, which you probably can't, honestly. I don't mean that as an insult. I'm just saying series. Series is rough. Okay, so we use that exact same series there, and we are going to figure out the Maclaurin series for f prime of x. I'm sorry, I got confused about which page was what because the bottom of the page is so close to the bottom of the screen here. And we see that we have the same interval of convergence as we did in the first part of the example. I think I've a considerable more bit of writing on my notes in class. I just don't have my notes with me. And I apologize. Okay, if you look at this next example, C, it is almost exactly like B, but instead of having x to the n minus 1, you have 3 to the n, or 1/3 to the n minus 1. So what you have going on here is instead of n x to the n minus 1, you actually, your general term would be n 1/3 to the n minus 1, because this little piece right here can be rewritten n times 1/3 to the n minus 1. So then we go down here and we see that it converges because x is less than 1, and we can put this in, and we also know that this whole thing, look all the way at the top, that is a geometric series, and we can use a, in this case, a was 1 all over 1 minus 1/3, which gives us 3/2. 1 minus 1/3 is 2/3. 1 divided by 2/3 is 3/2. So there you go. Once we integrate the function that we got to rewrite from the original page, and we integrate it using improper integrals, and we remember that Taylor series or Maclaurin series actually just it just represents the integral of the function that's at the very top of the page, right? Oh crap. Right there. Then we can actually find the sum. We have our interval of convergence, and I believe, if I remember correctly, this is all a fancy exercise to prove to you that the interval of convergence for a function, its derivative and its integrand are going to be equivalent. But the most important piece of all of this is that you remember that your functions like this are always going to look like something relatively familiar. So all of that down here is just in the same pattern as the function we just created, only, oh crap, wrong writing tool, poop, where this is just x plus 1/2 x squared plus 1/3 x cubed, yada yada. So this whole little stinking thing is just the negative natural log of 1 minus 1/3, or the negative natural log of 2/3. If you really want to get fancy, it's the negative natural log of 2 plus the natural log of 3. Yay! Sorry that was so long.